So hi guys, welcome to my channel. Today I'll be solving GFG problem of the day, which is count ways to nth stair where order does not matter. So let's see what question is trying to say and how we can approach this problem. By the way, the question is marked medium, but it will be very easy if you know the intuition behind this. So let's read. There are n stairs and a person standing at the bottom wants to reach the top. The person can climb either one stair or two stairs at a time. We have to count the number of ways the person can reach. Order does not matter. It's specially highlighted that order does not matter because if it not have mentioned here, so the answer would have changed entirely. So let's see, n is equals to 4 and output is equals to 3. So n is equals to 4. So let's dry run for n is equals to 3 if it is given. Okay, it is not given, so let's do for n is equals to 3. So if it is not given that order does not matter, so what would happen? Like, we can either take one step or we can take, okay, sorry, we can either jump one stair, so the remaining stair will be 2, or we can take 2 stairs, so the remaining stair will be 1. Now again we can take one stair, remaining will be 1, and if we take 2 stairs, so remaining will be 0. Now for this, if we take one stair, remaining step would be 0. If we take 2 stairs, it will be -1. Same again, if we do take one step, then it will be 0, and if we take 2 steps, then it will be -1. Now let's see, if we get the 0, we'll be returning that okay, we have reached at the bottom, so one way we got. If we reach the -1, so -1 is neither, like, it is not any like position where we can reach, so we'll be simply returning 0. We haven't got any answer, so we are returning from, like, if we are remaining with, if we have one step and we have to take one, like, if there are total stairs, we are left with 1 and we have to take one step or 2 step. So by taking one step we got one answer, and by taking 2 step we got no answer. So finally we'll be returning 1 plus 0, it will be 1. Now here also we get 0, so we have reached to the end, so it will be 1. 1 plus 1 is 2, so we'll be returning 2. Now here also we got one step, like, we have reached to the destination, so we'll be returning 1. From here we will be returning 0. From here we'll be returning 1. So finally we'll be returning 3. Now let's see that this we have taken one step, and one step, so we'll be writing here one step, one step, one step. Now we have taken one step and 2 step, so we'll be writing one step and 2 step, so all will be 3, all will be 3. Now here also 2 step and 1 step, so we'll be writing 2 step and 1 step. Now here order does not matter comes into picture, because if in case of 4 we are given that 1 2 1 2 1 1 and 1 1 2 all are considered same, so this and this are considered same, so we do not have to return 3, its answer will be 2. So now how we are going to solve this? Okay, let's see. So what we are doing is, what we can do is, we have 3, we have to take either one step or 2 step. So what we can do is, we can explore all the possible path with by taking one step, then we will be moving to 2 step. Before, what we are doing is, we have taken one step, then we have explored to 2 step, then we have taken one step, so we are just jumping to 2, then again jumping to 1. No, we are not going to do this. We have to explore all the path by taking one step. After completing it, then we will be shifting to 2. So let's see how we are doing this. So let's see, we have 1 comma 2, okay, and initially pointer is standing at 1. Now we can take this step or we can leave the step. So if we are taking this step, we will keep the 1 intact because we have to explore all the path by taking step 1. So we'll be remaining with 2. And what I have said, you will have to keep the step intact on 1 because we have to explore 1 first, then we'll be exploring 2. Now let's see, there will be 2 calls. So 1 will be, we can exclude 1. So 3 will be as it is. We have, like in this call, we have taken 1, so reduce to 3. We have exclude 1 and put our counter here, so it will be 3 as it is. So 1 comma 2. Now when we reached to 2, we will not be able to reach like use 1 any further. Like if this call will go further, we will be exploring like these step, the remaining step with the 2 step only. So let's see how we are doing. So 2, if we reduce 1, so it will be like 1 and keeping the index intact, so it will be there only. Now again we have to call. By the way, this call will goes like, we are excluding it, so 2 1 comma 2. Now we have excluded, so we'll be jumping to 2. Now from here it will be like 0 and 1 comma 2. 1 is intact. Now again this call will go, 1 will be as it is and 1 comma 2, it will be here. Now if we include, then it becomes -1 and 1 comma 2. If we will exclude, then 1 as it is and 1 comma 2, and the index becomes out of bound because whenever we are excluding it, then we are shifting our pointer but keeping the steps as it is. Now we will be seeing the base case. First we'll be handling this. Now it will be 2, so if we minus include it and exclude it, if we exclude it, 2 will be as it is and 1 comma 2, and pointer will move forward and it will go out of bound. Now for this call, first will be taking and second will be excluding. So if we will be taking, so 1 comma 2, pointer will be intact. Now here also we will be excluding, so 3 remain as it is, 1 comma 2, and the index becomes out of bound. Now for this call, including and then excluding. By including, it will become -1 bracket 1 comma 2, pointer will be intact, and here 1 as it is and 1 comma 2, pointer will move 1 step forward. Now we will be seeing that from where we are getting the answer. Now we have reached to 0, so whenever we reach to 0, we'll be returning 1, that we have get one path from which we are getting the answer. Now this -1, so we'll be returning 0, we haven't got any path. So from here also out of bound, then also we'll be returning 0. So here 0 plus 0 is 0 and 0, 1 plus 0 is 1, returning 1. Now here also we got 0, so we'll be returning we'll be returning 1 because we got one path. And here out of bound, then 0, 1 plus 0 is 1, we'll be returning 1, and finally 1 plus 1 is 2, we'll be returning 2. Now we can see here we haven't get any 0, like out of bound, so 0, here also out of bound 0, now here also 0 0 because out of bound, 0 plus 0 again 0, and finally 2 plus 0 is 2, so finally we'll be returning 2 as our answer. One thing you will be noticing that whenever we switch to 2 second index, so whatever call we are making, we haven't explored 1. Like whenever once we have reached to 2, we are not exploring 1 again. You can see here in this step we have reached to index 2, so in this call you cannot see that we have explored or come back again to 1. Why? Because once we have explored all the path from 1, then only we are shifting to 2, like here 1 1 1, then 1. So this way we are doing. And one more thing is like you can see here, we are repeatedly solving the similar problem again and again, where it is like we have solved this case 1 1 and 2 and 1 1 and 2. So to like avoid this repetition we can use dp. So let's move to code directly. So this is how, by the way, recursion is going and we are calculating the answer. Let's now see the code. So if n is less than 0, we'll be simply returning 0, or index becomes out of bound, then we'll be simply returning 0. Like in this case we can see that our -1 or index become out of bound, we'll be simply returning 0 and 0. So we have returned 0, or n double equal to 0, then we'll be returning 1, or n double equal to 0, n double equal to 0, so we will be returning 1. Now what I have done is I have put all my steps into the vector and passed it into the vector, passed 0 index, passing index, temp vector, and the steps we are like we have to reach. If n becomes 0 less than 0, return 0. If index greater than temp dot size, simply return 0. If n double equal to 0, then returning 1. And if we are including the step, then what we'll be doing, keeping the index intact and subtracting n minus temp of index. What we are doing, if we are including means this way we are going, then what we are doing is we are subtracting this index, temp of index, n minus temp of index is equals to 2. So we are doing this, and excluding means we are simply like moving the index one step ahead and keeping the n intact. Like in this case moving the step, initially it was in 1 and then it moves to 2, but 3 and 3 are intact. So this doing, and at last while returning will be include plus exclude. So while returning from this 1 and this 1, we are returning like 1 plus 1 is 2, so we'll be returning 2 above. So this way we are doing. So now compile it. It will be passing the initial test case, but it will fail. Okay, 0 index, where it is. Okay, dp. Okay, we will have to memorize, but let's see what is the problem we're facing now. It will pass for this, but it will give TLE, so we will have to memorize it by using dynamic programming. Okay, so it will be giving TLE. So now what I have told here is like we are repeating these same subproblems again and again, like this one, this one, this one, so this one. So we have to do memorize. So let me what is the first index that is changing is index, and till when till what maximum it can go is 2, like temp dot size, it is exploring this. So we'll be putting here temp dot size comma, and n is ranging, maximum n can reach here is n only, the n comma -1. For safer side we'll be giving n plus 1. Okay, now passing dp here, dp here also, dp, I'll be explaining it. dp of nd n is not equal to -1, then simply return dp of. By the way, this is the same problem you can like search on the net by the name of coin change 1 and coin change 2. The exact same problem, exact same approach we will be using there also. So let's run now. So what we are doing, let me see. Okay, it would pass. So what we are doing is we are initializing a dp table, dynamic programming, like table of sizes first, like index is maximum going to temp dot size, and n is maximum going towards like n, or to be on the safer side we keep n plus 1. Now if we do not, like here we are saving our answer, like whatever we are getting, like this one 1 comma 2, we get our answer, we store it in dp of index comma n. So initially it was filled with -1, but it will store the answer. Now we will be seeing that if it is not equal to -1, means dp of index comma n is already storing the answer, so we will be directly returning the answer instead of doing these calls. So this is how we are going to solve this problem, and I hope I have explained better. So thank you for watching and having patience. So thank you.